Hello, we are going to perform a quick demonstration on our project, which is about the DES algorithm. We implemented it using Java and Swing. The user is given a choice between encryption and decryption. We are going to start with encryption. So we have to enter a 16-digit hexadecimal message. Our code is written in a way that if we enter less than 16 or more than 16, it will give us a warning. And we also have to input a 16-digit hexadecimal key. So this is our message and our key. We are going to perform a set of operations on them in order to obtain the cipher. So first we perform initial permutation on the message to get this sequence, and permuted choice 1 on the key to obtain this sequence. We are going to perform 16 rounds of operation on our message to get the cipher, and for each round we're going to need a specific key. So this table shows the intermediate step that allows us to find this key. For each key, we take the previous one and divide it in two 28-bit sequences, perform left circular shift, and concatenate them. And we also perform permuted choice 2 on them on the result to get the key. So we added this information for the user. Now we're going to perform the same set of operations in each of the 16 rounds. So we start with this sequence that we obtained here. And in general, for each round, we take the output of the previous one and split it in two 32-bit sequences, left and right, and we perform operations on them. So we take the sequence on the right and perform expansion permutation on it, and XOR the output of this operation with the corresponding key. In encryption, if the round is, for example, round 2, we will take the key number 2 and XOR it with the output of this row. Then we perform substitution on the output of the XOR, and then permutation on the output of SBox. And at the end, we XOR the output of permutation with the left sequence of the previous round, and we get the result. The result is being the concatenation of the left and right. At the end, we shift and perform permuted choice 1, and we get the cipher. We're now going to perform decryption. We're actually going to use the same cipher and see if we get, with the same key, the same message. In DES, decryption is very similar to encryption. As we can see, initial permutation is performed on the cipher and permuted choice 1 on the key. The steps here are pretty much the same as in encryption. The keys are also identical, but the main difference between encryption and decryption is the fact that the keys are used in reverse order. So in encryption, we would use key 1 for round 1, while in decryption, we would use key 16 for round 1. And we perform the same steps and get the message, and we notice that the message matches the one that we used at the beginning.